Part A. Prove that sec 2a plus tan 2a is identical to cos a plus sin a over cos a minus sin a. Right, so we're going to start on the left-hand side here. And I'm going to rewrite the sec 2a as 1 over cos 2a. And I'm going to rewrite the tan 2a as sin 2a over cos 2a. You'll now notice that I have a common denominator, the cos 2a, so I can bring these two things together as one single fraction as 1 plus sin 2a all over cos 2a. Now to deal with the double angles here and here, because we can see we want to turn these into single angles. The sin 2a, there is only one way of me doing that, so let me rewrite that. So sin 2a, I know that's the same thing as 2 sin a cos a. The cos 2a, now we know there's three different ways we could do this. I could do it as, let me write them out quickly. I could do it as 2 cos squared a minus 1, or 1 minus 2 sine squared a, or cos squared a minus sine squared a. Now when I'm looking at the answer over here, I can see there's both causes and sines involved. So I'm going to pick the third option here, because it has causes and sines involved. Now, the other thing that I notice about the cos squared minus sine squared is that this can be factorised. This is the difference of two squares. So I could rewrite that as cos a plus sine a cos a minus sine a. And now I can see that this is starting to look a little bit like what I want. But I've still got this here, which I'm hoping is going to cancel with something on the top in a minute. Now at the moment it's quite difficult to see what to do with the top that's going to get that. Now, when I get stuck like this, a little trick that I like to use is to do a bit of rough working out on the other side of the identity. It is cheating a little bit because we shouldn't really do this, but to help me, why not? Let's just do a bit of rough working out over here. I can see that the denominator here matches up with this here. But I've got this extra cos a plus sine a. So what about if I took my right-hand side and I multiplied, let me just copy it down first of all, the cos a plus sine a, cos a minus sine a. What about if I multiplied that by this cos a plus sine a that I've already got on the denominator? So what about if I times here, cos a plus sine a, and obviously I'd have to do the same to the top. Then let me expand the brackets and let me see what I'd get. So on the numerator I've got cos a times cos a is cos squared a. Then I've got a cos a times sine a and a sine a times cos a, so that gives me a 2 sine a cos a. And then I've got a sine a times sine a. And the denominator just matches up with what I already had. Now, let's just have a look. I've got a cos squared plus sine squared. And I've got a 2 sine a cos a. Well, I've got 2 sine A cos A here. And I've got a 1, which I know does match up with the cos squared A plus sine squared A. So that's the trick that I need to follow here. I am going to rewrite that 1 as cos squared plus sine squared. That's the trick I'm going to use here. So let me do that. Let me go back to my actual working out now on the left-hand side. Probably going to need a little bit more space. So yeah, let me rewrite this 1 as a cos squared plus sine squared. And now I know from my rough working out that I did on the left-hand side. So let me just finish this line off. And yeah, I know from the working out I did on the left-hand side that this can be factorised to be this. So let me factorise that. So I'd get cos A plus sine A times cos A plus sine A. And that's all over the cos A plus sine A cos A minus sine A. And now we can see that this 2 terms cancel out and just leave me with the cos A plus sine A over cos A minus sine A, which is the right-hand side, which was what we needed to show. And I can now go and rub out that rough working out that I used to help me. And we have a full, complete proof. So a bit tricky, and I did have to do that bit of rough working out here to help me to get a clue as to what step to do when I wasn't sure how to rewrite the numerator. I did get stuck with what to do here. I didn't see immediately to rewrite the 1 as the cos squared plus sine squared. But it is a good little trick to do some rough working out on the other side of the identity just to give you a clue as to what to do next. Right, so let's move to part B of this question. Hopefully it's going to be nice and simple now, because it says, hence, so we're going to use what we just did. So notice we've got sec 2 theta tan 2 theta. That matches up with this perfectly. So instead of this, we can write this, but with theta instead of A. So I can say that cos theta plus sine theta over cos theta minus sine theta equals a half. I can now times this over here and times the 2 over here. So I'll get 2 cos theta plus 2 sine theta equals cos theta minus sine theta. If I now collect up the like terms, so let's move the sine thetas over to the left-hand side and move the cos thetas over to the right-hand side. So I've just moved that over there and that over there. We can then divide both sides by cos theta. So we get 3 sine theta over cos theta, which is 3 tan theta. The right-hand side is minus 1. Divide both sides by 3. I can now do tan inverse of minus 1/3. So let me type that into my calculator, making sure that we are in radians. So tan inverse of minus 1/3 gives minus 0.322 to 3 decimal places. I need to draw a tan graph so I can get the other solutions. radians. So pi over 2, pi, 3 pi over 2, 2 pi. We know we have asymptote at there and there. Our tan graph looks like this. And our solution that our calculator gave us was here. So we know there's going to be another answer here and another answer here. We saw that this was minus 0.322. So if I do pi, take away 0.322, and then I'll do 2 pi, take away 0.322. So pi, take away 0.322 is 2.820. And 2 pi, take away 0.322 is 5.916. And these are the two answers between 0 and 2 pi.